Good morning, Year 5, and welcome back to your maths lesson for Wednesday. Now, although this is the first time you are watching this is annoyingly for me the second time I'm filming it because my program has decided to just in general misbehave on me, to be honest. So here is your starter activity. Dexter is calculating 208 divided by 8 using part-whole models. Can you complete each model? So you can see there he's got 208 divided by 8 and he's got it laid out in 3 different ways. This isn't a method that we've looked at, but if you have a look and see how he's partitioned 208, you should hopefully be able to come up with the answers. So have a go with that, and when you're ready, press play again and we will go through the answers. Okay, then let's have a look. So he's partitioned in the top one, 208 into 80, 80, and 48. We know that 80 divided by 8 is 10, so 10 and 10 is 20. 48 divided by 8 is not 5, Mr. Benton, it is 6. So if we add those answers together, brilliant, we've lost it. 10 plus 10 plus 6 is 26. Now, if we look at the blue one, 208 divided by 8, we can say that he split it into 160 and 48. 160 divided by 8 is 20. 48 divided by 8 is 6. 20 at 6 is 26 still. And if we look at 208 divided by 8 and the green one, he split it into 160, 40, and 8. 160 divided by 8 is 20. 40 divided by 8 is 5. And 8 divided by 8 is 1. So each of those methods, each of those different ways of partitioning gets you the same answer, which is 26. Hopefully you might have been able to check this as well using one of the methods that we've been using over the last few days. So we're carrying on today and we are looking at dividing 4-digit numbers by 1-digit numbers using both the physical methods, the visual representations of it, and using the bus-stop method. So our first example is going to be 7,152 divided by 3. You can see that I have got my place value counter table, which has got 3 rows because I'm sharing it between 3 groups. I've got my place value counters, which have got 7,100, 5 tens, and 2 ones. So let's have a look through it and hopefully, no, okay, that's all right. So I've got 7 thousands, which go together like this. Now, unfortunately, I can't share that last 1,000, which means that I'm going to have to exchange that 1,000 for 10 hundreds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm sorry that it will come up like this, but I should end up with 1100s altogether. Now I can share those. 3, 3, 3. Now I've got 200s left over, which aren't going to share equally between 2 rows, which means I'm going to change those 200s for 20 10s. Now this one is not going to be quite as smooth. So let me get 5 10s, 10 10s, 15 10s, 20 10s. There we go. So because I can see that I've got quite a few there, to try and save some time, I can do a few of them at a time instead of just one. If you're not particularly confident with it yet, please don't try that method. Just do them one at a time if you're still not sure. As I start to get more, the most important thing is that they are equal each time. So you can see that at the moment, each row has got 7 10s. There we go. So now each row's got 8 10s. I've got 1 10 left over, which I can't use. So I'm going to have to exchange that for 10 ones, 2, 4, 6, and then let me take 4 of them. 10. There we go. So I've got 10 ones here, which I've exchanged, plus the 2 ones, so 12 ones altogether, which I am sharing between 3 rows. And I can see that I should, in theory, end up with this being equal. None of the questions that you're looking at today should have remainders. So if you end up with an answer that's got remainders, double check what you are doing, because these should all go in accurately. So we've got each row has got 2 thousands, 300s, 2, 4, 6, 8 tens, and 4 ones. So the answer is 2,384. And if I check that using my bust up method, 3 goes into 7 twice with 1 left over. 3 goes into 11 3 times with 2 left over. 3 goes into 25 8 times with 1 left over, and 3 goes into 12 4 times. So it still gives me the same answer. You can use skip counting to help you there if you're not that fluent with your multiplication facts. That's absolutely fine as well. Now for this one, that is I've got 3,765 divided by 5. So I've got my 5 rows and I've got my 3,706 tens and 5 ones. Now I can't share 3,000s between 5 rows. So straight away, I'm going to have to exchange these for 30 hundreds. Now, instead of you sitting and watching me do that, I know that I've got 30 hundreds to share between 5 rows. Now, 30 shared between 5 is 6. So what I'm going to do is I'm just going to put a 6 in here so that we know that with those thousands, we've ended up with 6 in each 100. Now I can start sharing the remaining hundreds that I've got. So I've got 7 hundreds left. So let's see. Where have we gone? Let me reorder this. Technology is not liking me today. There we go. 2, 3, 4, 5. Now I'm left with 200s, which I know that I'm not going to be able to share between 5 rows. So I'm going to exchange those 200s for 20 tens. Now, again, instead of sitting here and duplicating it for 20 tens, I know that 20 divided by 5 is 4, which means that each row would have 4 tens in it. So I'm going to do that just to save a bit of time. You'll notice that as you start dealing with larger numbers, it starts to get a little bit more cumbersome using the physical method. So this is where the bust up method is really, really helpful. So each row's got 700s in it. Now we know that each row has also got the 4 tens from our exchange plus 1, so 5 tens. I've got 1 10 left over, so I'm going to have to exchange that for 10 ones. I know that 10 divided by 5, or 10 shared between 5, would be 2. So I'm going to put 2s in here to show that. And then I've got 5 ones left to do. 1, 2, 3, 4, 5. So each row has got 700s, 5 tens, and 3 ones. So that the answer is 753. Now, if I have a look over at our bust up method, then I can check that again. So 5 doesn't go into 3. So 5 times 0 is 0. And then the difference between 0 and 3 is 3. So the 3 gets carried across and the 0 goes up there. 5 goes into 37 7 times with 2 left over. 5 goes into 26 5 times with 1 left over, and 5 goes into 15 3 times. So use either of those methods, or use both if you feel more confident. I know that some of you are having a go at using the scaffold on Teams. I know it's a little bit temperamental, so if you can persevere with that, brilliant. If not, then draw the representation of it and then attach a picture of your working is absolutely fine. So your arithmetic questions are here as well as on Teams. Here is your first batch of word problems. Second batch of word problems. And your challenge. For your challenge, you need to fill in those gaps with the greater than, equal to, or less than symbol. It's down as a separate quiz in the maths tab on Teams today. And here are the answers for your arithmetic questions, the answers for your first set of word problems, the answers for your second set of word problems, and the answers for your challenge. Best of luck with that, guys. Hopefully you are able to use the bus stop method very effectively by now.